Hello world, it's Rahul. Welcome back guys to machine learning tutorial. So we have seen so far how can we solve problems where we already have labels with us. But what if we don't have label in training data? So unsupervised learning came into picture that aids us in discovering patterns in our data related to various features. So guys, today we'll be going to study clustering mechanism where we organize objects into groups such that data points in same groups are more similar to the other data points in the same group and dissimilar to the data points in other groups. There are a lot more algorithms used for clustering the data points together, but today we'll discuss k-means clustering as this is the very basic one. So guys, k-means algorithm starts with initial estimates of k centroids, which are randomly selected from the dataset. The algorithm iterates between two steps assigning data points and updating centroids. Let's visualize all this, what I've just mentioned. Let's say I have some data scattered on the plane. So here I have defined data points in three different colors as these are creating different clusters when we apply k-means cluster on the data points. Let's first talk about the working functionality of k-means algorithm. Data is separated in k different clusters, which are usually chosen to be far enough apart from each other spatially. And for doing so, we use either Euclidean distance or Manhattan distance. Each cluster has a center called the centroid, and a data point is clustered into a certain cluster based on how close the features are to be centroid. K-means algorithm iteratively minimizes the distance between every data point and its centroid in order to find the most optimal solution for all the data points. So guys, let me mention few points what we have to do for creating different clusters for data points. First of all, k random points of data set are chosen to be centroids. Then distance between every data point and the k centroids are calculated and stored. Based on distance calculates, each point is assigned to the nearest cluster. After then, new cluster centroid positions are updated, similar to find a mean in the location point. If the centroid location change, the process repeats from step 2 until the new calculated center stays the same, which signals that the cluster's member and the centroids are now set. I know it's quite confusing for you if you are going through this for the first time, but you need not to worry as I will show how can we form clusters on data points, how can we select centroid and k value. Let's look into the dataset and try to solve the problem. So guys, as you can see on the screen, we have dataset which is having height and weight column, and by finding similar patterns we have to cluster them together. Let's assume that we want two clusters for the given dataset. So guys, as I've mentioned that first of all we have to initialize two clusters as k is 2 over here. So here I will select any two values from the table randomly. Let's say I am taking row 1 and row 2 as my two clusters. So centroid for cluster 1 will be 185,72 and centroid for cluster 2 will be 170,56. Now we have to look into other data point as well and assign them into either cluster 1 or cluster 2. But question arises, how to do that? So we will find the Euclidean distance for row 3 with cluster 1 and cluster 2. And we already know the formula for finding the Euclidean distance, that is square root of x of h minus centroid 1 plus square of x of w minus centroid of 2. Now we will calculate Euclidean distance for row 3 with both cluster 1 and cluster 2. So Euclidean distance for row 3 with cluster 1 will be square root of 168 minus 185 whole square plus 60 minus 72 whole square, and it is calculated as 20.80. Now we will calculate Euclidean distance for row 3 with cluster 2 as well, and that would be square root of 168 minus 170 whole square plus 60 minus 56 whole square, that is 4.48. So as you can see, Euclidean distance for row 3 with cluster 2 is less as compared to cluster 1. So row 3 will be assigned to cluster 2, as we need to assign to the nearest cluster as mentioned earlier. As row 3 has been assigned to cluster 2, now our centroid value will get changed. We will take mean of 170 plus 168 divided by 2, comma 60 plus 56 divided by 2, and now our updated centroid value will be 169, 58 for cluster 2. Now we will check whether row 4 will go to cluster 1 or cluster 2. Let's calculate Euclidean distance for row 4 with both cluster 1 and cluster 2. For cluster 1, square root of 179 minus 185 whole square plus 68 minus 72 whole square, that is 6.32. And for cluster 2, square root of 179 minus 169 whole square plus 68 minus 58 whole square. So guys, if you notice here, I am using updated centroid value for cluster 2, and after calculating this, we will get it as 14.14. So Euclidean distance for row 4 is less in case of cluster 1. So this row will be assigned to cluster 1 only. As data point has been assigned to cluster 1, now we will update the centroid value for cluster 1 by taking mean of centroid value and row 4 value, that is 185 plus 179 divided by 2, comma 72 plus 68 divided by 2. And now our updated centroid for cluster 1 is 182, 70. Likewise, we will repeat the same steps till we complete for all the data points. At the end, we will get two clusters as shown on the screen. It will cover all data points and final centroid values as well. Thank you guys for your time. Do like, share and subscribe. Hit the bell icon to get the latest updates. Happy learning and stay safe.